Hello, everybody. Welcome back. Today we're going to be looking at Unit 4.8, which is called Introduction to Acid-Base Reactions. And we've actually talked a little bit about acid-base reactions already. And I told you all before, later in the school year, there is an entire unit that's going to give us a lot more detailed information about acid-base reactions. But we're just going to dive a little bit deeper into it today. So let's get started. All right. So just to review with you, we've actually already seen this slide before, but I just want to review with you a little bit of vocabulary about what a Bronsted-Lowry acid is, what a Bronsted-Lowry base is. Okay, remember that a Bronsted-Lowry acid is a compound that gives away or donates its hydrogen ion. Where does that hydrogen ion go? The base, the other reactant, will accept it. And remember what we said, that a hydrogen ion is sometimes referred to as a proton because really that's all it is. It is just a proton. So sometimes you'll see the definition written like that. Now, there's a little bit more vocabulary here, and I want you to look at this reaction up here and let us understand that there is no element A. There is no element with the symbol A. So this is just meaning any random acid, okay? And let's just reaffirm those definitions. If you look at HA from left to right, what is happening to it? It's donating away its hydrogen ion. Where is that hydrogen ion going? Water is accepting it. So HA must be the acid and water must be the base. Now, there's a little bit more vocabulary here. There's a new vocabulary term for you, conjugate base. Whatever is left of the acid after it has done what acids do. After it has given away its hydrogen ion, what is left of it? Well, if you look at the example above, that would be A-. That's called the conjugate base, okay? The word conjugate, I want you to interpret that as what something becomes, okay? So the acid, after it gives away its hydrogen, becomes the conjugate base. The conjugate acid is whatever the base becomes after it does what bases do, after it accepts that hydrogen. So H2O becomes H3O+. H3O+ is the conjugate acid. Okay? So you're going to have, particularly in multiple choice, you're going to have questions that give you a reaction and say, you know, what is the acid in this reaction? What is the base? Or what is the conjugate acid? What is the conjugate base? Okay. And one final thing, if you look at the product side and you look at where the conjugate acid and the conjugate base are, why are they called conjugate acid, conjugate base? Well, look at H3O+, the conjugate acid. Look at it from right to left. If you look at H3O+ on the right-hand side and then move your eyes to the left, what it becomes if you were to look at this reaction backwards. H3O+ becomes H2O. How did that happen? It must have given away its hydrogen. That's why it's called a conjugate acid. Because if you look at the reaction in the reverse direction, H3O+ gives away a hydrogen. What does A- do? It, from right to left, accepts a hydrogen. So we call it a conjugate base because from right to left, it accepts that proton. So let's look at some examples here. And if you want to pause your video, all I'm asking you to do here is in each example, identify the acid, the base, the conjugate acid, and the conjugate base. So pause your video and see if you can figure this out. All right, let's see how you did. So in number 1, those are the appropriate labels. So HOCN from left to right donated away its hydrogen, so it becomes OCN minus. OCN minus thus is the conjugate base. OH minus is the base on the left-hand side because that hydrogen that got donated away was accepted by the OH minus. All right, let's check how you did on number 2. Okay, and finally, number 3. You'll notice in number 3, the base was written first. The order of your reactants, guys, does not matter. Okay, sometimes it's acid plus base, sometimes it's base plus acid. Doesn't matter. Your conjugates are always going to be on the product side. Your straight out acid and base are always going to be on the reactant side. So that was a quick one. Mostly just vocabulary, and as I said, you'll see those kinds of questions typically in multiple choice, sometimes in free response. And again, we will look at a unit much later in the year that is going to go into much greater detail on acids and bases, but we'll get there. All right, so I hope you've learned a little something today, and I look forward to seeing you next time.